Hi, my name is David Aiken and I'm a Windows Azure Technical Specialist. I'm going to talk to you about how you can build global and highly available services using Windows Azure. What I thought would be great is if we looked at some of the big questions that we get from customers. As the load increases, are you still available? If the platform fails, are you still available? And this is sometimes my question back to the customer. How do you think about a global reach? And finally, if the compute is close to the user, what about the dependencies? What can we do to help there? I have to make some assumptions so we can get through all the material. So first of all, you need to know the basics. This is web worker roles, SQL Azure, using Windows Azure Storage, tables, blobs, queues. It's good if you're familiar with asynchronous programming techniques, as well as Windows Azure diagnostics. If you're not, now's a great time to go and research those things and come back. I'm also going to make the assumption that you've deployed a service already to Windows Azure, not necessarily in production, but as a tester or maybe as a QA. One final statement is, and I'm pretty sure you'll agree with me here, everything can and will eventually break, and we have to plan for that. So why do services fail? Well, one of the biggest things we see is an increase in workload, and this is sometimes, we've gone through testing of the application, we've deployed it into production, we're starting off with a few thousand users, but then as time progresses we end up with millions of users and we're just not able to handle the increased workload. So that's one reason why those types of services fail. Other is just general failure. Hardware fails, network issues, platform service isn't available. There are also some transient conditions that you have to deal with when you're working in a dynamic environment such as Windows Azure. And then finally there's good old human intervention. Sometimes we fail because we've touched it, we've done an upgrade, we've made a code change, we've deleted something accidentally. So what do we mean by available? Well, when we hit the app, when we hit the service, do we have the same functionality? Does it increase the response time? Do we get slower? But have we still got the same kind of functionality? Then we've got the option of being degraded slightly. So maybe we can upload photos, but we can't resize them. Maybe we can add new things to our shopping cart, but we can't actually do a checkout. And then finally, there's fail-safe mode. Nothing works at all. Rather than displaying an error message, can we get some sort of, hey, we're busy fixing this error, we thank you for your business, come back later kind of question. So let's go and take a look at the first kind of set of things. As the load increases, are you still available? So a couple of puzzles to start off with. First of all, what's wrong with this? It's a typical kind of web app. It's got a web role, several instances there, talking against a SQL Azure database. It's probably the most simplest architecture for a web app you could possibly have. We see this time and time again. And what's wrong with this? Well, if we've got n of those and one of those, as another clue, we all get how to scale out websites, right? We take the web server and we duplicate the web server. We build a web form. In Windows Azure, we can do this really easily by deploying more web instances. But then it comes to the database, and it seems our total strategy for database scaling is to add more stuff to the database. And by stuff I mean adding CPUs, adding memory, faster disks, tuning the file system, tuning the indexes. We go to town, but it's still within a single box. And one of the things that one of the concepts you've got to grasp when you're working with the cloud is that you've got to scale out everything. So this is my first kind of piece of advice to you, is if you're building an app and you have multiple web instances running, do think about scaling out the database. And just as an example, people get hung up on, hey, SQL Azure limits 50 gig or 150 gig. I normally encourage people to scale out for throughput before they scale out for size. And it's better to have 51 gig databases than it is having one 50 gig database, purely because we potentially can put 50 servers onto that same workload. So do think about that. And it's the same principle as a website. Following on and building on that, what about this diagram? Well, it's the same setup. We have some storage, we have some external dependencies. Here we're actually decoupling the work from the web role. We're using a queue into a worker role. We have some SQL Azure, we have some table storage, we have some blob storage. We actually publish scalability target figures for queues, tables, and blobs. And reading that and understanding what's going on with those services will help you figure out how many queues you need, as an example. If you want to go and be able to churn through thousands of requests per second through a queue system, you're going to need to build more than one queue to handle that workload. Equally, if you want to go through a huge number of entities in table storage, you may want to consider having multiple storage accounts or multiple tables to handle that workload. So you're really taking the web role and you're thinking about, IIS can have a certain amount of throughput, and when we want to break that, we go and deploy 2 servers. Take that same model and apply it to all of the storage and all of the dependencies that you might have. So as the load increases, are you still available? So scale out everything. We might want to partition data. We might want to store some users on one database and other users on another database. We might also want to just make copies of the database. If we are in a very read-intensive environment, then it's a great strategy to copy out the databases. Another thing to think about is how you actually create the database and what data goes in a single database. So if we've got some product catalog and then we've got some orders, we might have 2 databases, one for the product catalog, one for the orders. We might then partition the orders database out by customer, and we might actually just replicate the product catalog several times in its entirety and achieve scale through that. The next thing to think about is testing. We get a lot of people trying to build big stuff on Windows Azure and on premises as well, and they don't test it. They don't test it at scale. Testing with half a dozen developers hitting the site is one thing. Testing with 10,000 requests per second gives you a completely different story. So I encourage people, if you're working in the magnitude of millions of users per day, you need to figure out how to test at that level. The other kind of piece of testing, which is unrelated but we should mention it anyway, is around security testing. More and more we're building apps that now have public endpoints that can be accessed by anybody, and we should do some sort of vulnerability testing on our application to make sure that we're not exposing any IP or personal information out. Then getting feedback. One of the great things with Windows Azure is its ability to collect all of the diagnostics information from all of the instances that you have running and push it out into storage where you can go back to it later and analyze what was going on. It's great because it allows you to collect a baseline over time. It's a pretty much turn on and forget kind of scenario. But you do need to make sure that you have this on, because if you don't and you're trying to troubleshoot a performance or a scalability issue, it's extremely hard to do that when you're in the error condition if you don't know what normal looks like. So we might look at the CPU. If it's sitting at 80%, we might be, oh, it's a CPU problem. But without a baseline, we don't really know if it's the CPU or not. Last week it might have been 80%, and 80% is fine. Last week it might have been 20%. We don't know. So I do encourage you to set up diagnostics. One thing to note is diagnostics does push into a storage account. If you want to do this right, have a separate storage account for diagnostics data. That way you don't have any contention with your production data. It just makes it really easy to manage. You can also give more people access to the diagnostics data without giving them the access keys for production. Another great thing on feedback is to set up some sort of external monitoring. Now, Windows Azure itself doesn't provide any application-specific monitoring. We keep an eye on the health of the instances and the VMs, but we don't ping your application to see what's going on. So it's worth setting up some external monitoring just so you get that outside-in view of what's going on. So if the platform fails, are you still available? Now this works on the principle that something will go wrong eventually, probably. And we've seen cases where we're just not geared up to handle that. Even within our own data center, we'll get problems, and we know how to handle those. We have some sort of operations guide put together to handle business continuity DR situations. The same really applies no matter where you're running. And if this is in the cloud, in Windows Azure, then you need to think about the same types of things. Now, great news with Windows Azure is we give you a bunch of things free. We give you the ability to easily deploy compute resources. You can deploy your website with 5 compute instances, 5 web instances, and if you need more capacity, you can hit essentially a dialog box, change the number of instances you have deployed, and we take care of deploying those extra compute instances. And we do all sorts of things. We go and find space in our data center to put those new compute resources. We go and wire up the load balancer and the VLANs that we create with your application. We update all of the monitoring that we do as well. So it really is a couple of mouse clicks and you can get more compute power. We also keep an eye on those things. So if you've said, I need 5 web instances, we're going to keep you at 5, and we'll detect bad nodes and we'll automatically recover those. Now, recovery might be redeploying your application onto a completely different set of hardware, extending the VLAN, updating the load balancers and firewalls and all that kind of stuff as well. But we take care of that automatically. There's no action required to keep you at that service level. We also, being mindful of failure, and if you operate data centers at the scale we do, then if you just take the mean time between failure of a hard drive, you can probably figure that one's just failed right now. So to kind of mitigate against that and accept and embrace the fact that something could go wrong, we actually deploy you across different fault boundaries. So we've divided our data center up into different domains where they have a reliance on, say, power or networking, and the goal there is to deploy you in enough places so that a single outage doesn't take your entire app out. So if you've deployed 5, we might get a switch failure. Switch failure might take out a whole domain. If we take out the whole domain, you may lose a couple of instances. You'll still be running, you'll still be available, and we'll start the process automatically of recovering your application onto 2 new nodes. So building on the fault domains, we actually have an SLA, and the SLA is designed to have 2 or more instances, and the reason for that is we know that if we just had 1, we're going to have some downtime. The final thing we do is around our storage, and every time you store some information in Windows Azure, whether it's in blobs, tables, queues, or SQL Azure, we actually go and create 3 copies of that within the same data center. So it's not 3 copies, 2 copies in one data center and 1 copy in another. We actually create 3 copies within the same data center. We keep them perfectly in sync. The other thing we do with blobs, tables, and queues, blobs and tables, is we go and replicate that to another data center within the same geographic region as well. So we have incredible high-level resilience built into the storage system, and it's just part of what you pay your standard fee for. Now, one of the key design principles of Windows Azure is to be self-healing. I sometimes compare this to the Terminator from the movies. And it doesn't matter what you do to the Terminator, it keeps on coming. Windows Azure is the same. No matter what we try and do within the data center, it keeps trying to fix itself. It keeps trying to work around hardware failures and network failures and power outages and anything else that might affect it. So we're going to keep your service running. We're going to keep it going at all costs. The question is, can your service handle that? When we build applications for on-premises, a lot of the principles for recovery do involve human intervention. So the app's down and we have to recover the SQL database. Someone will go and manually recover that database. They'll then go and probably update some configuration, maybe roll back a few transactions or clean up some things, and then enable the application again. In Windows Azure, all of this repair of different services is going to happen automatically without notifications. So what you need to be able to do is codify those types of operations. You need to be able to detect things when you've got an outage with SQL Azure, or some dependency you can't contact. You need to be able to automatically be able to absorb that kind of thing and respond, but also be able to recover from it. We also have the ability to provide in-place upgrades. So if you have to deploy version 1.1 of your application, we do have the ability, we have several ways of doing this, but we have the ability to do an in-place upgrades where we actually replace the application a machine at a time, or a group of machines at a time, into the next version. Now there's different strategies, and we don't have time to dig into each one right now. But it's worthy of further investigation around how you do upgrades. Again, we have the same principle of dividing your application into domains, and we'll only upgrade a domain at a time. This means if you've got 10 instances deployed and you've got 5 upgrade domains, we're going to do 2 instances at a time to get you upgraded. Configuring that is real easy. You go in your service definition CFDef file, and you can specify the upgrade domain count and set that to whatever level you want it to be there. And the final thing on fault tolerance is around what we call transient data center conditions. And my simple statement there is, do you have retry logic? So let's dig into this. What do you mean retry logic? Well, sometimes things don't work the first time you access them. This could be SQL Azure, it could be table storage, it could be the service bus, it could be your third-party credit card processing service, it could be your third-party encryption service. There are going to be times when, because of networking, because of the service itself, or other conditions, where you try and make a request and the request doesn't actually get anywhere. Or it does get somewhere, but the machine's too busy to respond, or gives you a temporary error. Now with a transient fault, pretty much what you need to do is simply retry the operation. And a lot of the time, this is just going to work. Now all of our services have a finite amount of capacity within them. We've already talked a little bit about the performance goals of table storage and blobs. But SQL Azure also has throttling built into it as well. And this is partly to protect the service, it's partly protect your application as well. What you're going to do though is you're going to experience times when you will get particular errors back. And if your application's a typical run-of-the-mill application, you're probably going to throw an exception, you're probably going to redirect the user to some error page, you're going to log the error, and the sky is falling in. If you really want to kind of build a system to absorb these and to be Terminator style, what you need to do is retry the operation. Now you can write some code to handle that yourself. We also have a block. There's a transient fault handling framework, and in fact if you visit that site, there should be a link onto the latest version of that, which has just been released shortly before we recorded this. And the goal really is to retry against anything that might have these types of transient conditions. SQL Azure is a great one to think about. Table storage, Windows Azure Storage actually has the retry logic built into the client. So you already have the ability to attach a retry policy to that. And when I talk about a retry policy, it's not that you want to kind of try the operation and then immediately try it again if it doesn't work. You probably want to back off a little bit and say, we got a problem, we're going to wait a second and we're going to try it again. And if it still fails, we may be going to wait 5 seconds and then try it again. And if it still fails, maybe we'll wait 20 seconds and try it again. And if it fails 3 times in a row, then we'll accept it's down and we'll mitigate against it. So we want to kind of think about backing off the retry as well. But take a look at the transient fault handling block, and that'll give you more guidance on how to implement that. So thinking globally, we've talked a little bit about what happens within the data center. We keep our application running. We're going to redeploy instances if we need to. Everything is pretty good. But what if we're building an app that's going to be used worldwide? We could choose to put our data in the US, but people in Asia are going to have that huge, massive round trip to get into the US. Same goes for Europe. So where do we put our data? Where do we put our compute? Is there anything we can help with? Well, great thing with Windows Azure is we do have some technologies in the mix to help with this. Now, two things. One, first of all, network latency. Wherever you are, there is a path to get between you and the data center. And the further away from the data center, potentially the slower that connection will be. So if we can put the compute or the data closer to the end user, then we're going to reduce that round-trip network latency. The next thing about thinking globally is around availability. If we take the everything will fail to the extreme, then we could basically say, hey, what if our data center went down? What if we lost the North Central data center for a few hours? What would happen? Could you handle that kind of outage? So you might also think about using some of these global technologies to handle outages that occur at the data center level as well. And obviously the challenge with this is how do we synchronize data between different deployments? If we're going to deploy our application into 2 data centers or 6 data centers, we've now got a problem of how do we synchronize the data between those different locations. So network latency we talked about. The further away from a point from a data center you are, the more latency will play into the equation. And there's a couple of things we can do with that. First of all, one technique is to serve out static content or which might be coming from blob storage or compute from the edge network. So a CDN, or a content delivery network, is a set of data locations where we can actually cache objects. These objects could be videos, they could be CSS, they could be JavaScript, they could be any type of static content. It could also be movies. We can actually do streaming across the CDN as well. And the goal really is, we could deploy your application into, let's say, North Central US. And if you're accessing any of this static content from within Europe, what's going to happen is you're going to basically hit a point of presence that is within Europe or is somewhere closer to your location. And what we'll do is we'll basically figure out, does that object already exist at that CDN endpoint? If it does, great. If not, we'll go and get it back from the blob storage. So this is great. We have 24 plus endpoints worldwide, providing an amazing level of caching and performance. And it is so simple to implement. There are a couple of mouse clicks to enable storage and to enable the CDN on storage. You don't have to pre-populate storage pre-populate the CDN. You can just connect it up to blob storage and we'll take care of populating that on demand for you. You also have control of the cache timeouts, so you can impact how long it stays in the CDN and also how long it would get cached downstream as well. So that's kind of static content. What about compute itself? Well, we do have the ability to deploy to as many data centers as you like, but how do you get the traffic routed to the best data center? So the goal of Windows Azure Traffic Manager is to direct users to the closest region. Now, closest region is kind of a little bit misleading because you can actually define how Traffic Manager routes people to which data center. And we have several different ways of doing this. We call these policies. So let's imagine I'm a client, my IP address is 1234, and what I've done is I've deployed my Foo app into 3 data centers. I've put one in the US, one in Europe, and one in Asia. Now, when I go and access my app, I'm going to make a call for foo.net. Now, foo.net is going to go to a DNS server to get resolved. Eventually, it'll work its way around to our Traffic Manager, which basically is going to provide a DNS response. Now, Traffic Manager itself has a set of policies which you've defined, and here what we could do is say, look, I want to respond based upon the performance. So this is the performance really of the network between where the client is and where the particular data center is. So In this case, we're in 3 data centers. We're going to look at the client 1, 2, 3, 4 and figure out, based on performance, where should we send them. Now, to do this, we do a whole bunch of monitoring. We do a whole bunch of monitoring of the network. We collect a huge array of network statistics. We also monitor your application as well, and this comes in quite useful in a moment. So based on all of that, we then provide a DNS response. So that DNS response could be foo-azure.cloudapp.net, in which case you'll then go and do a DNS lookup for that IP address, get the IP address, and the client will make a connection to it. Fantastic. Now, this monitoring thing is important because when you wire up this to Traffic Manager, we're actually going to poll your applications on a regular basis to determine if they're available. And if they're not, so let's say we're pinging, we're polling foo Azure. Let's say after a few tries we don't actually get a response from you. We're going to take that out of rotation. So we'll stop routing traffic to that data center. We'll keep monitoring it because when you bring your app back online, we'll actually automatically configure that back into the Traffic Manager. So what I want to do is just take a moment to flip across into the web browser and actually show you how easy it is to set up Traffic Manager. So I already have signed into the portal here. This is the current portal. It may change, but the principle should be the same. So I'm going to go into the networking and I'm going to find my Traffic Manager. And here you can see I've got a Traffic Manager policy defined for an app called Humble Me. Now, Humble Me is a pretty amazing app. It basically is a URL shortener. So you enter a URL in there, you click on the button, and you would get a short version of the URL. I currently have that app deployed into 2 locations. I have a one deployed into North America and one deployed into Western Europe as well. And it's exactly the same service in both places. Then in my policy, if I go into configure this, I can show you the policy, and we've got a choice. We can choose between performance, which is, let's route the person to the right data center based on performance. We can also just do it based on failover. So here we'll try and send everybody to the service that's highest on the list, and we'll fail over to the next one down on the list. This is great for when you have a more complicated application and perhaps the data requirements mean you can't actually run live in 2 sites. And then finally, in this version of Traffic Manager, we have round robin, which will simply do exactly what it says. It will just load balance between the 2 on a round robin basis. The other interesting thing to note is we actually have a monitoring endpoint. So here I've specified basically a URL, which is, in this case, is app path, app health. Now, app health returns a completely awesome message if the app is running. And here you can see, if you see this page, everything is fine, and that's wonderful. Traffic Manager really isn't looking for any text here. What it's looking for is a 200 response. So any valid 200 response is good. If you send an error response back, then Traffic Manager will think it's offline. And I'm going to show you this in a moment. The final thing is what the DNS name is. Mine's humbleme.ctp.cloudtrafficmanager.com. This is the CNAME that I'm going to point my real DNS entry to, in which case mine is www.humble.me. And then we have the DNS time to live, and the smallest time to live there is 5 minutes, which is 300 seconds. So it's a fairly simple configuration. We need to deploy our application twice. We need to figure out the data, and we'll talk about that in a moment as well. And then you wire up a Traffic Manager policy, and you let us take care of the rest. And we're going to route traffic based upon performance, right up until the point one of these fails. And once it fails, we're going to start routing traffic to the other one regardless. And remember, the DNS we set to 5 minutes, so it's going to take about 5 minutes to do a failover on this. 5 minutes sounds like a hideously long time, but 5 minutes is actually shorter than you getting an alert, signing into the portal, and starting to figure out what's wrong. By the time you've kind of done that, usually 5 minutes have elapsed. In the case of Traffic Manager, you're up and running again. So that's kind of one part of the puzzle using Traffic Manager. But if we've put the compute next to the user by deploying to multiple data centers, then what about those other dependencies? What about storage? What about service bus, ACS, and all those kind of things? So, our strategy here is to really think through all of these services and what's the best way to provide a DR kind of scenario for this. Now, as with anything, we're at various degrees of implementation throughout. So Windows Azure Compute, it's really easy. We're just going to deploy, and Traffic Manager is going to handle a failure for you. That's great. For things like SQL Azure, we have a data sync service, and we're going to show that in a moment. But that allows you to sync data between two databases. They could be in two different data centers, as an example. Other things, we right now, our solution is to really think about how many of these you would need. So in the case of Service Bus, maybe you create two namespaces for the Service Bus. For cache, maybe you're creating multiple cache locations as well. So really think through about using and scaling out again across different data centers these types of services. Now, what you've got to think about in the case of a SQL Azure outage or a Service Bus or something like that, if part of the platform fails, can we survive without that? A great example might be reporting services. If reporting services was unavailable, your app could probably do quite a lot even without that one piece. So you have to think about that. You also have to design your app to be able to kind of detect reporting services isn't there and actually adapt the UI so that users keep trying to click on that report that doesn't work. You can also think about using the same platform service from another data center. And one of the things that I did with Humble Me is if I have a SQL Azure outage, I could have switched across to use a SQL Azure database in another data center. However, what I decided to do was if SQL Azure doesn't work, I should just fill the entire app across into the other data center. And that's the last bullet. Can your service not use that platform service temporarily? That could be an option as well. But you've got to decide on an application and a dependency basis which one's right for you, and then figure out the right way of meeting that need. Now, my approach is if a site-specific dependency is out, we should just fill the whole site across. So rather than trying to work around a SQL Azure outage and potentially using a SQL Azure database from another data center, we should probably just route the traffic across. Now, you could hard code your own method of doing this. There are some third parties you can use as well, and of course we've just talked about Traffic Manager for doing that. So let's look at how Traffic Manager handle this. And while we have an outage, we're going to simulate an outage here. While we have an outage, we're going to show you how we set up the synchronization of the database and a few other things that we've talked about. So I'm going to flip it back across into my app, and I want to actually show you the UI. It is truly stunning. I'm sure you'll appreciate it. Rich HTML5 content there. The thing to note really is the background is orange. Now, if I go to the North American site and hit the URL directly, you'll see the background is actually orange. If I go to the European side, you see the background is actually grey. Now, this is very important because when we do the failover from here, how we know it's going to fail over is because the background color will change. So depending on which data center you hit, you'll get a different color. Now, in order to simulate this, we have a page called fail status. And basically, I hit the site, I'm going to tell it how long to simulate a failure for. The failure simulation is quite easy because we have that app health page, and basically what we're going to do is alter the behavior of this page. So we're not really taking SQL Azure out or anything like that. We're just going to make this page return a 404 error. So let's go and simulate this failure. We'll go and do it. We'll have a 15-minute outage. Thank you very much. We'll click on fail, and it is quickly as that. We can flip back to here, and if we refresh that, we get a 404 back. Remember, Traffic Manager is looking for a 200 response, so sending anything else back that's not a 200 response is pretty much telling Traffic Manager you're out of service. Now, if I go into here, what's going to happen is Traffic Manager is going to take a couple of passes at hitting the site before it actually marks it as bad. In the current CTP version, it does it every 30 seconds, and we have to have a couple before we actually flag it up as bad. One thing I do want to do is I want to show you the DNS resolution for humble.me. So if we open up a PowerShell window there and we go and resolve that, you can see it's actually returning back NA humbleme.cloudapp.net. So that essentially means we're hitting the North American data center. That's what our DNS resolution actually is doing right now. Now when we come back later in this demo, we're going to try this again, and we should see that we get a different answer back from the NS lookup, and that's Traffic Manager kicking in. So while this is kind of refreshing, what I want to do is show you a little bit more about the application and some of the things that we've done based on the content of this video. So if I go into Data Sync and I expand out my setup, I actually have created 6 sync groups. Humble means 0 through 9. Sorry, 0 through 5. That would be 6, wouldn't it? What I've got is I'm deployed, remember, to Europe, and I'm deployed to North America, so I actually have a SQL Azure server in both locations, and I've set up bidirectional replication between the one in the US and the one in Europe. Because I partitioned my database out, I actually have 6 databases. So instead of storing all of the short URLs in one database, I'm actually using and spreading this across 6. So you'll see I actually had to create 6 sync groups to be able to do this, and they're all basically mirroring exactly the same database. If I wanted to add a new database in, it's fairly straightforward. I'll click on Add Database, and then I can choose from my list of servers that I have available, and then I can pick a database, and then I can check the credentials and then add that to the mix. So configuring this is amazingly simple to do. I can also decide how to handle conflict resolution and exactly which tables are going to be synced across and which direction they're going to be synced as well. While we're in CTP with this service, we're syncing every 5 minutes. That's the fastest you'll be able to sync within the CTP. Obviously, depending on the data that you're using, 5 minutes might not be fast enough. Now, if we flip back to the virtual network, and I just want to refresh my browser just to make sure it's going to pick up that data as soon as we can. That will take a second to load up there, and we'll bring up the virtual network, expand Traffic Manager again, have a look at our policies. You can see it's actually offline on there. Now what should be happening now is any of the new DNS lookups will be pointing everybody to Western Europe. Now what's really interesting is this gets cached all the way downstream. So when I do an NS lookup, I may actually get North America. Now fortunately we didn't here, we waited long enough for it to time out. It went back to the DNS server, and you can see we're now being routed to the European site. If I open up a new Internet Explorer and do a refresh on there, in fact, one thing that we've got to be mindful of doing here is I'm just going to check the internet cache is on there. In fact, I'm going to delete the temporary files as well, and then we can do a Control and F5 just to simulate a new user. And expertly cached. Oh, there we are. Convincing IE to go back to the source and get the new data. It's pulled down, and the background now has gone to grey. The reason why we had some trouble getting IE to go and do that is everything is cached on the site, and the only change really between the two sites is the style sheet, and there's orange, grey is the two changes there. So that's why it took a little bit of effort to get that to come back. But you can see that was fairly kind of painless. Users, who were actively using the site are going to get a small outage while they can't hit that production site. But as soon as their client does a DNS name lookup again, you'll be back up and going. Now, it does mean you have a blip, but recovery time is pretty quick in that case. So, just to summarize, Windows Azure provides a lot of capabilities to keep you running and to help you scale out. You deploy an application, we actively monitor that application's health from an instance and a compute resources point of view, and we redeploy those instances if we need to. You need to think about scaling out. You can scale out websites really easy. Everyone gets that. Everyone gets the ability to build out web forms and that kind of thing. Everybody then it goes to storage and approaches that from I have a single SQL server or I have a single database kind of viewpoint. You have to think about scaling out the database. Things like table storage and blob storage already provide this scaling inbuilt as part of the service. Things like SQL Azure have features that allow you to deploy lots of the same database, to deploy the same database and slice it up differently. We have federations coming along as well. And all of those technologies really allow you to scale out the database. So we're not going to have one database. We're going to have n number of databases, tens of databases, hundreds of databases. The next thing to think about is how you handle those kind of glitches within the data centers. How do you handle those glitches with any of your dependencies? And the best way to think about doing that is to handle those transient conditions. And do use the transient framework to help with that. Operations should be codified. We're going to automatically redeploy your application. Can your application handle that when it fails? And then consider using some of the global features such as Traffic Manager and Data Sync to deploy your application into multiple data centers, not only for global reach and putting compute and storage next to your customers, but also doing it for availability as well. The chances of 2 data centers going down at the same time has got to be slimmer than anything else we've got going. And now that I've said that, clearly we'll have 2 data centers go down. Anyway, I apologize for that one. Thank you very much. I hope this has been useful.